Picture this, timeless olive groves, trees that have stood for generations. But what happens when the very ground that feeds them just runs out of steam? How do you bring life back to soil that's been worked for centuries? Well, that's exactly the challenge we're digging into today. So yeah, that's the big question, isn't it? How do you rejuvenate soil that's been farmed for hundreds, maybe even thousands of years? It's a huge problem for farmers all over the world, not just in these ancient groves. And we're going to focus on the Mediterranean, where these iconic olive groves are facing a really modern problem. Their soil is just exhausted. It's often what's called calcareous, which basically means it's chalky and alkaline. It's lost that rich organic matter that plants crave, and it's become hard and compacted over time. To solve this, scientists decided to call in two potential heroes for the soil. You can almost think of it like a buddy cop movie. You've got the seasoned veteran teaming up with the hotshot rookie. So in one corner, we have compost. This is the veteran. We all know compost. It's packed with nutrients, and it gets all the good microbes in the soil buzzing with activity. And in the other corner, we've got biochar. This is the newcomer. It's this incredibly stable, porous material that acts like a sponge for water and can stick around in the soil for centuries. Okay, so what in the world is this biochar stuff? Well, it's a special charcoal-like material that you make by heating up biomass, think wood chips, in a container with very little oxygen. This process creates this amazing honeycombed structure. It's kind of like building a luxury apartment complex for water and microbes right there in the soil. All right, so we've got our two contenders. But theories are one thing. What happens when the rubber meets the road? To find out what really works, researchers in Spain set up a pretty ambitious 5-year-long experiment in a real working olive orchard. So here's the game plan they followed. They took a 25-year-old organic grove and split it into 4 zones. One area was the control, they didn't touch it. The other 3 got either pure compost, pure biochar, or a blend that was 90% compost and 10% biochar. They'd add these treatments every couple of years and then just measured everything. The soil, the trees, even how many olives they got. And after 5 long years, the results started rolling in. The first big takeaway? The treatments had a huge positive impact on the soil itself. Take a look at this. This graph shows one of biochar's amazing superpowers. See that dashed line way up top? That's the soil that got the biochar treatment. It could hold on to way more water. It basically turned the topsoil into a super sponge, which in a dry climate is an absolute game changer. But here's where it gets really interesting. Each treatment had its own specialty. Biochar was the undisputed champ when it came to the soil's physical structure, holding water. But for kicking microbial life into high gear and making nutrients like nitrogen available, that's where compost and the compost blend really shined. So, the soil is officially healthier. It holds more water, it's packed with nutrients, it's teeming with life. That should be the end of the story, right? Happy ending. Well, this is where our story takes a really unexpected twist. I mean, this is the whole point, isn't it? Did all these fantastic improvements in the soil actually lead to happier, more productive olive trees? And the answer, incredibly, was no. Just look at the data. There were no statistically significant changes. Not in the crop yield, not in the nutrient levels in the leaves. After 5 years of pampering the soil, the big, established trees barely even seemed to notice. So what gives? All that work and the trees don't care? It seems like a total failure, but the scientists had a hunch. You see, an adult tree is like a massive ship. It's really, really slow to change course. So to get a faster, clearer signal of what was really going on with the soil's fertility, they set up a brilliant second test. This time, they grew little baby olive plantlets in soil taken from all the different test plots. These little guys would be super sensitive to any changes in the soil quality. And this was the aha moment they were looking for. For the young plantlets, the results were night and day. All the treatments helped, but that compost and biochar blend, it was a total rock star. Just look at their root growth. It was more than double what they saw in the untreated soil. This was the proof. The soil was incredibly fertile. So it turns out the answer wasn't compost or biochar. The real magic, the secret sauce, was putting them together. The researchers themselves put it perfectly in their conclusion. A combination of compost and biochar may provide a synergistic effect. That word right there, synergy, that's the key. It means the two together are way better than the sum of their parts. And the logic behind this is actually really elegant. The biochar provides the house, a stable, porous structure that holds water. And the compost provides the food, a rich buffet of nutrients and microbes. You put the house and the food together, and you've created the perfect neighborhood for plant roots to move into and thrive.
Now, this is all fantastic science, but it doesn't mean a thing if it's not practical. So we have to ask the ultimate question. Can a real farmer actually afford to do this?
Well, if a farmer wanted to use pure biochar, the cost would be a pretty big problem. The study estimates it's around 1,200 euros per hectare. For most people, that's just a non-starter. But what about our winning blend? Because it's 90% compost, which is way cheaper, the cost absolutely plummets down to around 255 euros per hectare. Now that is an affordable, realistic strategy. And so, the final verdict is N. The compost-biochar blend isn't just some theory. It is a powerful, long-lasting, and most importantly, a cost-effective solution for nursing these ancient, tired soils back to health for generations to come. And that leaves us with one last thing to think about. This whole study revealed a powerful synergy between two pretty simple materials. It really makes you wonder, doesn't it? If a simple blend can work this kind of magic on ancient soil, what other powerful partnerships are out there, hiding in plain sight, just waiting for us to discover them?